Hello, friends. Today, in continuation with previous video on effective pressure in the soil mass, in the last video, you have seen what is the effect of uh, capillarity or capillary water. How does it affect the uh, total pressure, pore water pressure, and the effective pressure? Now, what is the effect of Artesian pressure? So we will like to see the effective stress due to Artesian pressure in soil. So let's take a problem to understand this. Let's say you have the problem is shown here in the figure. So problem is as per figure, and figure is here. This is the ground surface, ZL, and first 3 meter is 0.0. There is 3 meter from the ground level. It is sand, and if you go further down up to 8 meter, that is remaining 5 meter, it is clay, and followed by impermeable rocky ground. It is sandstone. Now, it has been found that below 8 meter, if you go it by 1 meter further down, here there is a Artesian pressure, or below 8 meter there is going to be Artesian pressure. The water is confined between two impermeable layers, and because of that there is Artesian pressure. So if you go below this in sandstone, there is going to be Artesian pressure, and the groundwater table is 1 meter below the ground level. So in the sandy layer, groundwater table is shown here, and this is 1 meter from the ground level. Now it's found that below 8 meter in sandstone, there is an Artesian pressure. And when you put a piezometric tube over here, the piezometric tube in the sandstone, due to Artesian pressure, the water level is going to shoot up to this level. And this level from the ground level is 4 meters. So at this point in sandstone, which is at a distance z in sandstone, the pressure suddenly shoots up because of the aquifer, Artesian pressure. It is shooting up from the ground level, it is shooting up by 4 meters. And the unit weight here above the groundwater table, the total unit weight of this moist soil is 16 kilonewton per cubic meter. And below the groundwater table, gamma saturated is 20 kilonewton per cubic meter. And for the clay, gamma saturated is 22 kilonewton per cubic meter. So you will have to calculate the effective pressure at 0, at 1, at 3, 8 meter, and also in sandstone and in sandstone at a depth eight plus z meter. So it is found that below 8 meter in sandstone there is an Artesian pressure at depth z. As shown in figure. So this is the depth z. This is the whole problem. And what we need to calculate is clearly defined in this problem. So effective pressure. So the effective stress has to be calculated. And you know, to compute the effective stress, you need to calculate. So solution part, we need to calculate total stress, sigma, pore water pressure, U, and then sigma minus U becomes the effective pressure sigma prime. So we can easily calculate the total stress or total pressure at 0 meter. So in a tabular form, if you want to calculate, that is the easiest way. So if you want to calculate at z equal to 0, Then at 1 meter, 3 meter, 8 meter, and 8 plus jet. So this way, we can compute it, and gamma is already known to you. So the total pressure or total stress sigma in kilopascal can be computed. At 0 meter, the total pressure is going to be 0. So it is 0. At 1 meter, it is going to be, the unit weight is going to be 16 and depth z is 1. So gamma t into z, this becomes 16 kilopascal. Now at 3 meter, it is going to be 16 plus. Now from 1 to 3 meter, that is for 2 meter, the unit weight is going to change from 16 to 20. So it is 20 multiplied by 2. So it is going to be 20 into 2, that is 40 plus 16, it is going to be 56. So this pressure is going to be 56 kilopascal, right? And at 8 meter, now it is already 56 plus. From 3 meter to 8 meter, that is for 5 meter, the unit weight is going to change to 22. So 22 into 5. So it becomes 110. So it becomes equal to 166 kilopascal. And at 8 plus z, it is already 166. Let's say the unit weight of sandstone is gamma s. So for this depth z, at it will be gamma sandstone multiplied by jet. So this is the value of sigma. Now you can calculate the value of pore water pressure in kilopascal. The pore water pressure at 0, there is, if you insert a piezometric tube at here, there is no water level. So this becomes height of water into unit weight of water. This becomes 0 here. At 1 meter, there is no height of water above that. So HW is 0. So it becomes 0. At 3 meter, if you come over here and insert a tube, piezometric tube, the water will rise up to 2 meter. So it is going to be gamma HW becomes 2, and gamma W, here it is given that take gamma W, the unit weight of water, equal to 10 kilonewton per cubic meter. For simplicity of calculation, we have taken this. So it is given in the problem that gamma W is to be taken as 10. So at 3 meter, it is the height of water, that is 2 meter, multiplied by unit weight of water 10. So it becomes 20 kilopascal. Then if you go to 8 meter, the water will rise in the standpipe by a distance of 5 plus 2, that is 7 meter. So from 1 meter to 8 meter, that is 7 meter into 10. So pore water pressure is uh, at 8 meter, it is going to be 10. It is going to be clay. C for clay. So it is clay. S for sand. Now, if you go below sandstone, now the pore water pressure, if you put a standpipe, it shoots up by further 4 meter. So the height of water here, the pore water here is already 70, and the effective pressure here the pore water pressure is 4 plus 8, and let's say Z is in the near vicinity of this sandstone, just here, very near. So then uh, it is going to be 8 plus 4, that is the height of water is going to be 1. 8 plus 4 becomes this. So it is 12. So in the near vicinity, say this point is very near, just below the clay layer in sandstone. So it is going to be this 8 meter, and the water has shot up by 4 meter under Artesian pressure. So HW is going to be 12 meter. So 12 meter multiplied by 10, so it becomes 120 kilopascal. So the pore water pressure you have calculated very easily, and at different level. Now, what is the effective pressure in kilopascal? That is very important, because your strength parameter is a function of the effective pressure. So effective pressure is difference of total pressure minus pore water pressure. It is going to be 0. There is going to be 16 minus 0, that is 16. And at 3 meter, it is going to be 56 minus 20, that is 36. And at 8 meter, it is 166 minus 70, 96 kilopascal. Now, the total pressure is 166. Here, the effective pressure is 96. So, 96 is the effective pressure, right? So, if you are going very near to that, or you can say, if the point lies just here, then what will happen? It is 166 minus 120. You can find it out. So you can the pore water pressure has exceeded by 5 meter, 50. So here 166 minus 120. So it will give you the value So due to poor water pressure, the effective pressure reduces considerably to 46 kilopascal. It was 96 at 8 and just below because of the increase in artesian pressure. So this pressure has gone down. So effective pressure is going to be quite less, which you can see it. Just below that, the pressure moves up by 50. From 70, the pore water pressure, this is going to be 1 meter and plus 4 meter. So 1 meter plus 4 meter, that is 5 meter, 5 into 10, that is 50. So 96 minus 50 equal to 46. So effective pressure was 96. You can see here, just above this, it was 96. Just below that, because of the Artesian pressure, the pressure is shot up. The groundwater table is here, 1 meter below the ground level. It was 1 meter below the ground level. But just below that, because of the Artesian pressure, the pressure has shot up by 5 meter, 4 plus 1. So your effective stress will go by 5 into 10. That is, pore water pressure is going to increase because of the Artesian pressure. So Artesian pressure is going to be of paramount importance here, and one should look to this problem. Friends, I have deliberately taken this problem so that you understand how this Artesian pressure is going to play with a reduction in the effective pressure. And once the effective pressure is going to reduce, the shearing strength is going to reduce drastically, because your strength is a function of the shearing strength is a function of effective stress. So this example is very important for all of you, and such problems I have seen being asked in conventional examination, UPSC, also in GATE examination. So I will, in the next video, I will throw little more light on effective pressure concept, and that will be all for effective pressure. Then I will be taking permeability, the next chapter, which is equally important for all of you. Thank you very much.